Is Marcin. I'm a postdoc at ETH, and today I want to present our work we already published last year at ACM SOC, and it's the idea of serverless processes, a new, more powerful model for serverless computing. The motivation for our work are stateful workloads that we can see, for example, in microservices. Here in the example of a very simple LaTeX microservice like the one we see in Overleaf. All of the data, like updated LaTeX code that we submit to the cloud service, will land in some function. But there, the function cannot cache any data locally because work requests may be sent to different functions that operate at the same time. They may end up in the different containers. So every single time when we want to get text or update text, we have to use persistent cloud storage. So even if we have some local state, because we have free memory in Lambda, we cannot rely on this. Furthermore, if we think about requests like getting the PDF, if we just compiled a few seconds ago and we want to download the PDF again, user click compile button and then they want to get a PDF, we cannot rely on the cache again because maybe we will end up in a different container. So we have to rebuild PDF again, which is expensive. So we can use the storage, which adds latency and the cost. On the other hand, if we think about how to deploy this to a traditional microservice, we know that we can employ things like sticky sessions to make sure that the requests always end up in the same container from the same user. We can rely on caches, and we do not have to pay the latency and actual monetary cost of using something like S3. And of course, we could build one service that is optimal, one serverless service that has very specific domain optimizations for microservices. But instead, we thought that maybe for this type of workload, we actually need a programming model that is general purpose, not only for microservices or scientific computing, but is more powerful. And here we went back to the drawing board and thought about how traditional cloud models like containers or virtual machine look like and characterize them across the dimensions of memory location, persistence, computing resources, and the cost. What we notice when comparing to serverless is that we're going in a different direction quite radically. There are many, many changes. And our proposal is that we can fit something new in between that has the state persistence of a container, but still has a ephemerality of computing resources like in serverless. What we propose there, we call it process as a service, PaaS. There, we get the state that is usually available just for a few minutes, like in a traditional serverless containers, but we provide the guarantee that the state will be retained, even if we don't use it for a longer time. However, when we want to invoke functions, we still want to only pay for the actual CPU time. In this model, we take inspiration from the classical operating system process model, and we provide cloud process. Instead of having threads, we have computational functions. Instead of using memory, we have a local state that can be objects as in our implementation, but could also be some memory. And we, instead of using IPC methods like queues or pipes on the operating system, we provide a uniform communication channel with a mailbox. This way we can guarantee that we can always deliver data even when our process is not active at the time. To work with this, we provide a very simple communication model that works in the two-dimensional time space. If we want to communicate with a function that does not exist yet, this is simply invoking a new function. If we instead send data to ourselves to be used in the future, we are storing this in the local state. We have separate functions for that. And if we want to communicate with a different process alive at the same time, we have the cloud inter-process communication with a different API for that. And we demonstrate this in the paper on several different workloads. Here I show example of this very simple LaTeX microservice. And we deployed a few different requests like getting file, getting PDF, updating file. We deployed this on the Lambda with different configuration, and we deployed PaaS on Fargate containers because we rely on the external IP address availability. And here specifically for the requests that get the data, we can be significantly faster. For updating file, we are not as much faster, simply because here we need to actually persist user data in external cloud storage, because for our state of the process, we do not provide the guarantee that it's replicated nine times. Thank you for the for attention. You can find more details in the SOC paper. There will also should be a video from the SOC presentation on our YouTube channel. The implementation is on the GitHub, and I welcome any questions you might have.
Please share those links. I mean, I know that slides are on the website, but share those links in Discord channel. I think it makes it much easier to
do.
Any questions to Marcin?
A fast one, Marcin. So rather than a new paradigm, this is not more like a programming abstraction that you build on top of functions and some indirect communication middleware, like for example, some in-memory layer or some event-based service or storage layer. So this is not kind of a new programming abstraction on top of existing cloud resources?
Yes and no. So this can be implemented on top of existing resources. So for example, the communication can be direct, it can be relied with something like in-memory cache or storage. But this is more about providing a new abstraction both for communication and the state. I focus on maybe a little bit too much in the presentation on the communication, but I think our main focus is really providing you the state, making sure that if you keep invoking functions in the same process, you always touch the same state. Even if the container is removed, your state will be swapped back from the cloud storage.
Okay, thanks.
Okay. If there are any other questions, please ask them.
Thank you for the question, Pedro.
Thank you. If you have any other question, please ask them at the end of our session or ask them in our Discord channel. Malekabbasi, Mohammed, can you start your presentation? Okay. Looks good. Go ahead.
Yeah. Hi, I'm Mohammadreza, Malekabbasi, Reza for short, and I'm from Scalable Software Systems at TU Berlin. And I'm happy to introduce Umbilical Choir, our approach to automated live testing for serverless applications that span the edge and the cloud, which is also related to one of the future topics suggested. And before we dive in, I want to acknowledge that the recent war situation has been weighing on my mind, but I will try my best to deliver this presentation and stay in 5 minutes. So companies do daily releases and frequent updates thanks to CI/CD pipelines. And while this agility is great, more releases causes more risk of degrading service quality, right? But to manage this risk in traditional cloud environments, live testing has become a standard practice. Existing cloud testing tools maybe work for centralized microservices, but not for edge to cloud-wide FaaS environment, because they aren't built for geo-distributed, heterogeneous edge environments. And FaaS platforms also lack advanced testing features, anything beyond simple traffic filtering between versions. And this forces developers to implement error-prone, non-scalable custom solutions. So we introduce Umbilical Choir, a framework using a tree-like hierarchy of release managers and agents, allowing us to manage tests across edge and cloud in a platform agnostic way, using a proxy for traffic control. So the internal nodes, as you can see, release managers here, oversee a specific geographical area or just a logical segment of your deployment. They plan and delegate strategies to their child nodes, as you can see left to right. The release managers with no child nodes or leaf nodes are what we call agents. And they are actually the components that directly interact with the underlying FaaS platforms where your functions run. So Umbilical Acquire is scalable, it's geo-aware, FaaS platform agnostic, and considers edge network limitations like no push access, no SSH access. So how does a developer actually use Umbilical Acquire? They define what we call a release strategy, ideally in a human readable format, specifying test stages like A, B, or canary. And as you can see, the release strategy is made of multiple stages and function versions that are defined on top. So for each stage, the developer specifies multiple parameters. For example, how much traffic to send to different versions. And the result of a stage is either success or failure based on a predefined metric conditions like error rate or response time. And developer can choose to roll back, roll out, or just name the next stage to run. Furthermore, in edge to cloud, we need to be smarter about where and how we roll out. For instance, testing a new feature in a specific market first or roll out during the off-peak hours in certain time zones. We propose and support 4 basic strategies. Global incremental, where all locations increase traffic together at the same time, like this. And local sequential, where one location fully adopts the new version before the next one starts, like this. And the regional variation of this. These strategies alone or combined give developers fine-grained control over their releases. Our open source prototype demonstrates feasibility of Umbilical Acquire. While our proxy adds some latency, it enables vital testing capabilities. Most importantly, Umbilical Acquire successfully managed a complex multi-stage release across both edge and cloud nodes. So to wrap up, Umbilical Acquire addresses the critical need for better live testing in edge to cloud FaaS. By automating complex geo-aware release strategies, it helps reduce risks and allows developer to deploy new features with greater confidence. Thank you.
Thank you. Please share the link. I don't know where the QR code is going, but if possible,
Sure.
please share it.
Sure. And I'm open for any questions if there are.
And any questions? Please remember to unmute if you ask the question. Okay, I would ask the same question, but how do you see use of AI to make easier to write the YAML or maybe even debug it?
For live testing, you mean, or
when you specify like what you want to happen? Yes, live testing or anything like that, to make it easy to create, like you just specify high level and then AI could figure out what exactly should go in your specification.
Yeah, so if we have actually the basically have our nodes and their configuration, we can ask for like very conservative or actually more confident releases for some tests, or just run A/B tests for comparing some versions of a function, and just collect the results back and decide to roll out. So basically generating something, yes, like the YAML file instead of the developer, and the system can just do the rest.
Sounds good. Thank you.
Yeah, sure.
Okay. Our last talk in our workshop. Bartosz, are you ready?
Yes, I'm ready.
Let's hope it all works. So far, we had a very good, experience. Everybody succeeded. So you are the last one.
Right. So 100%.
I can see your screen.
Success.
You are ready to go.
Can you see my slides? Can you hear me?
Everything okay. Looks
Yes,
like
great. Thank you for the introduction. So my name is Bartosz Balis. I'm from the EGH University of Kraków in Poland. And today I will be talking about cloud native management of scientific workflows. So scientific workflows are these large graphs of tasks that could be anything from 10K to maybe 1 million tasks even. And they are widely used in computational science, in scientific computing in general. The distinctive features of these workflows is that they have these parallel stages. So many tasks can run in parallel, but different stages can have quite different characteristics in terms of, for example, resource usage or task length or anything like that. So Kubernetes is a very attractive platform for executing such computations for various reasons. I want to mention in particular the cloud agnostic nature of Kubernetes, which makes it attractive as opposed to, in this respect, for example, cloud functions, which are quite vendor specific. Yes. So the objective is to develop a service that allows to serverless or semi-serverless, let's say, execution of these graphs of tasks on top of Kubernetes. And the solution is this. So we have developed autoscalable worker pools. So the important design detail here is that these pools are Kubernetes deployments that use horizontal pod autoscaler, but they are class specific. So each type of job has its own job queue and its own deployment, which is sensible because jobs of the same type will be similar. So the pod sizes, let's say, will be similar. So that's the only sensible approach. And this is actually an update from the work that I have presented 1 year ago. Specifically, we have added and investigated vertical scalability in addition to horizontal scalability. So here is a detailed architecture. So we have developed this custom resourced controller, a worker pool resource. So you can, using this YAML, you can actually deploy a number of resources that create an autoscalable worker pool for you. So this works on top of multiple components here. We use the KEDA operator. KEDA is nice for autoscaling that is driven by any metrics you like. So this was, and also scaling to 0 was very important, because if there's an empty queue, you don't want any pods in your cluster of the given type. And there is actually the scaling metric is here. One version of it, at least, it just computes the number of replicas for a given worker pool that should be instantiated in the cluster. And multiple worker pools can compete. If this is the case, there is a certain resource quota in the cluster, and the scaling of these multiple worker pools will be proportional to their lengths of their queue, which is one actually version. Just the lengths of the queue, it's not a perfect version. We have actually been playing with different variants of this metric, and there is actually a lot of nice tweaks that you can do here, maybe to take into account the length of the job, is so that many short jobs do not dominate the entire quota of resources over a few long jobs, for example. And these are a few concluding slides just to show you some results. So this is a run of a workflow, about 16K tasks, I think, in a Kubernetes cluster. So here you can see a run without worker pools, and there are a few problems can be seen in this run. For example, this gap here occurs. On the bottom, you have the cluster utilization, basically, in terms of the number of parallel jobs. And this gap is due to overload of the Kubernetes control plane. Now this is the same execution with worker pools, so the make span is much shorter and the utilization is much better. Then we have added vertical scaling. This is a different cloud was used for it. So this is without vertical scaling. We use vertical pod autoscaler for that. So you can see the make span is maybe 1800 seconds. And with vertical autoscaling, which adjusts the requests of pods dynamically, the make span is significantly shorter. Also, the parallelism is larger. So actually, it is a very promising direction to have both horizontal and vertical autoscaling for your, let's say, task executors. Yeah, thank you. This concludes my presentation.
Thank you, Bartosz. Any questions?
A fast one, Bartosz. No, very interesting, the idea of horizontal and vertical autoscaling. My question is related to, I mean, when you need vertical, maybe you need it because in your pipeline, you have a stage that maybe you need like doing something in memory or you have a reason to have vertical scaling, and this should be normally explicit. How is in your case? I mean, do you think this can be transparent or it should be something that the user should specify beforehand?
Yeah. The question is if the user can specify that. And also the idea of serverless execution is that the user is not concerned with this, but the infrastructure adjusts not only the number of executors or replicas of pods in this case, but also their sizes. Yes. So with Cloud Functions, you need to choose explicitly the size of your function, and you have only typically just a number of sizes to choose from. I think a step forward from this model is to actually scale your functions, let's call it, or tasks, also vertically, without the user having to know or specify anything.
Okay.
Okay, any other questions to Bartosz or any other presenters? Before we finish workshop, maybe we can try to do another group photo screenshot of everybody who is present. So if you want to be in that screenshot that we will then post on Blue Sky, Twitter, or LinkedIn, just enable your camera. Well, if you want to change your username, you can also change, if you right-click in list of users, you can give yourself whatever name you want. Like there is an option to change your name. So, yeah, so when everybody is ready, just smile and just think about it. It's like if we were an actual physical location, it's kind of group photo approach. So I will give it another like 5 seconds, and then whoever wants to be, please turn on your camera. And use whatever screenshot tools you have to take a screenshot and then post it into Discord channel. So, you know, we will choose the best one looking or something. So, okay. Everybody ready? Let's start countdown. 3, 2, 1. Remember to smile. Serverless. AI. Okay. I will do one more, but that's it. Thank you. And this is more or less the end of the workshop. We would like to make it a little interactive at the end. So, you know, if you have questions that you want to have recorded, it is still recording. And very soon I will switch off the recording so you can kind of talk off the mic, you know, informal, if you want to raise any questions. This is the forum. And of course, you know, if you want to follow up in Discord channel, that works too. Any questions or ideas? Okay. 1, 2, 3. Okay, I'm switching off the recording. Thank you, everybody who participated in the workshop, and looking forward to see all of you. I will post the call for papers for the next workshop that will be in middleware, which is the hybrid workshop as well. So if you have the paper submitted to middleware or, you know, to our workshop, we are looking forward to you. Because it is hybrid workshop, also if you have some short presentation or demo or anything like that that you want to show there, you are most welcome. And as Pedro was saying, we also look on anything related to serverless and AI. What is the future of computing, essentially? Like, you know, when you are building all those things, how AI can help, or how end users, humans, can contribute, because I think that may be one of the winning use cases to make serverless computing even working for non-developers. I'm turning off the recording.